Okay, so Trig Basics, this is Unit 8, Day 1. This is a short unit. We are not going to have an actual test on this. It's kind of like Unit 7. We're going to put it on the midterm. Okay, so let's just start. We're going to start with Pythagorean theorem. You guys have done Pythagorean theorem before, so this should be mostly review. But let's just go through it. So Pythagorean theorem, that's a squared plus b squared equals c squared. And this is on right triangles. So C is always your hypotenuse. And if you don't remember that, that would be a good thing to write down, that C is your hypotenuse. And then A and B are the two sides that are connected to the right angle. So C is the hypotenuse, opposite of the right angle. A and B are the two sides. Those are interchangeable. It doesn't really matter. Okay? Let's look at example A. So we have to find the missing side. First, let's label our parts. So I'm just going to call 4A, 8B. Again, those are interchangeable. It doesn't really matter. But X is C. X is the hypotenuse, so that one's always C. Now I'm going to write my equation. So I have A squared plus B squared equals C squared, which is 4 squared plus 8 squared equals C squared, or you can substitute that with an X. I don't know why I didn't. Which is 16 plus 64 equals C squared, which is 80 equals c squared. Square root both sides. The right side of that's easy. The square root of c squared is just c. So I have c equals the square root of 80. Now I need to break down that radical. I need to simplify it. So I'm going to make a factor tree for 80. So 80, 2 times 40 is 80. 2 times 20 is 40. 2 times 10 is 20. 2 times 5 is 10. Now those are all the prime factors at the ends of this, okay? And normally I would draw lines in between this, like there would be a line right there, and right there, and right there, and right there. I just couldn't figure out how to get the computer to do it. So draw those lines to help you. But then I'm going to circle my pairs. So I have a pair of 2's and I have another pair of 2's. So I'm going to pull both of those out, and I'm left with c equals 2 times 2. And then the square, or 5 is all that's left, so that stays underneath the square root. And then 2 times 2 is 4, so c equals 4 square roots of 5. Okay, you have done all of this last year. This is all in secondary too. So this should seem kind of familiar to you. We're pulling on your prior knowledge right now, okay? Let's look at B. So again, let's label A, B, and C. So I'm just going to say that A is X, B is 22, and C is 24. C has to be 24 because that's our hypotenuse. Then I'm going to square everything out. 22 squared is 484. 24 squared is 576. Now I need to solve for X. So I'm going to subtract 484 from both sides. I get X squared equals 92. Square root both sides. I get X equals the square root of 92. Now I have to break down the square root of 92, so I'm going to make another tree out of this. So 92 is 2 times 46, which is 2 times 23. Those are all prime, so I'm going to circle my pairs now. I have a pair of 2, so I'm going to pull out 1, 2, because for every pair you pull out 1. So that's 2 square roots of 23. Okay? Alright, let's get into some new stuff. You might have done this last year, I don't really know. So, first some definitions. A trigonomic function is a function whose rule is defined by a trigonomic ratio. Okay? A trigonomic ratio compares the lengths of two sides of a triangle. And then the Greek letter theta, that's that O with a line through it, is used to represent the measure of an acute angle in a right triangle. Okay? So, C is our hypotenuse. Always. I'm over right underneath this triangle. C is my hypotenuse. We talked about this when we were doing Pythagorean theorem. Now it's the same when we're working with right triangle trigonometry. So my long side is my hypotenuse. Now I'm going to look at my angle. And where my angle is, so where that theta is, I'm going to draw a line. Whatever side I hit, that is the opposite side. Okay, so from that angle, I drew my line, hit that side, so that's the opposite side. Which makes the other one, the one that's right next to it, the adjacent. and adjacent means right next to. Opposite is opposite of the angle, then your hypotenuse is always the longest one. Okay, so we're going to label all of our triangles that way. Then we're going to use this acronym right here, so SOHCAHTOA. That's sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And I like to write it this way because then it really shows us sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. Okay? So let's start with sine, cosine, and tangent. Sine is opposite over hypotenuse, which is opposite is A, hypotenuse is C. So in this triangle, it's A over C. Cosine is adjacent over hypotenuse, which is B over C. Now tangent is opposite over adjacent because it's TOA, so that's A over B. Okay, now reciprocal functions. So reciprocal functions are basically opposite of sine, cosine, and tangent. Okay, so sine and cosecant are opposites. Cosine and secant are opposite. Tangent and cotangent are opposite. So tangent and cotangent are easy to remember because it's just tangent and cotangent. They both say tangent in the name. For sine and cosine, sine starts with an S and cosine starts with a C. So sine pairs with the one that starts with a C. So sine pairs with cosecant. Cosine pairs with one that starts with an S. So cosine pairs with secant. So it's sine and cosecant, cosecant and secant. So we have SC, CS. So we just have an SC, SC in both of those. Okay, that's a little trick to remember that. If you want to remember it a different way, that's fine, just as long as you remember it. Okay, so cosecant, if that's the opposite of sine, I'm just going to flip that fraction. So instead of being opposite over hypotenuse, it's hypotenuse over opposite, which is C over A. Secant is the opposite of cosine, so that's going to be hypotenuse over adjacent, which is C over B. Okay, and then tangent is the opposite of cotangent, so that's adjacent over opposite, which would be B over A. Okay, now let's actually find some of these. So find all 6 trig functions for theta shown in the triangle below. Well, first we need to find our missing side, and we're just going to use Pythagorean theorem to find that. So we have 16 squared plus 30 squared equals c squared, which is 256 plus 900 equals c squared. 1156 or 1156 equals c squared. Square root both sides, you get c equals 34. So I'm just going to label that 34. Now we're going to label our sides. So the one opposite of that right angle, the longest side, is the hypotenuse. I'm going to draw a line from the angle. That's the opposite side, which means the other side's the adjacent side. Now I'm going to use my SOHCAHTOA acronym. So sine is opposite over hypotenuse. So sine, opposite side is 16. Hypotenuse is 34. Reduce that fraction. 2 goes into 16 8 times. 2 goes into 34 17 times. And then that doesn't reduce anymore. Now let's do cosine. Cosine is adjacent over hypotenuse. Adjacent is 30. Hypotenuse is 34. 2 goes into both of those. So that reduces down to 15 over 17. Okay, now tangent is opposite over adjacent, so that's 16 over 30, which is 8 over 15, because 2 goes into both of those again. Now, if we find sine, cosine, and tangent, cosecant, secant, and cotangent become easy to find. Cosecant is the opposite of sine, so I'm going to flip that fraction. That's 17 over 8. Secant is the opposite of cosine. Again, flip that fraction, 17 over 15. Cotangent is the opposite of tangent. Flip that fraction, that's 15 over 8. Okay, let's look at example B. So given the ratio for cosine, we need to find the remaining ratios. So we're given that cosine of theta equals 2/3. So I'm just going to draw a right triangle. There's my right angle, there's my theta. Now cosine is, oh wait, before we do that, let's label our sides. So the longest side is the hypotenuse. Draw a line. The one you hit is the opposite, which means the other one's adjacent. Now we are given that cosine of theta equals 2/3. And cosine is adjacent over hypotenuse. So that means the adjacent side is 2, the hypotenuse is 3. And then I need to use Pythagorean theorem to solve for that missing side. So I have a squared plus 2 squared equals 3 squared, which is a squared plus 4 equals 9. Subtract that 4 over. You get a squared equals 5. Square root both sides. You get a equals the square root of 5. And you can't take the square root of 5, and 5 is prime, so we can't break that down. So I'm just going to label that opposite side the square root of 5. Now I can go through and find the rest of these trig ratios. So sine is opposite over hypotenuse, which is the square root of 5 over 3. We already found cosine. Tangent is opposite over adjacent, which is the square root of 5 over 2. Now cosecant is the opposite of sine, so I'm just going to flip that. That's 3 over the square root of 5. Secant is the opposite of cosine. Flip that. That's 3 over 2. Cotangent is the opposite of tangent. That's 2 over the square root of 5. You're done. Okay, let's do the last couple examples. So now we're using trig to find actual side lengths given an angle measure and a side. Okay, so let's look at example A. We need to find x. So I'm just going to write my SOHCAHTOA acronym, and I'm going to start labeling the sides. So 25 is my hypotenuse. And I'm going to draw a line from my angle, and I hit the opposite side. So on this one, I have opposite and hypotenuse. Which one uses opposite and hypotenuse from sine, cosine, and tangent? It's sine. So I'm just going to write this out. It's the sine of the angle, so sine of 64 equals opposite, which is x, over hypotenuse, which is 25. Okay, and now I just have to solve this for x. And the way I want you guys to do this is I want you to make them both fractions. So I have sine of 64 over 1 equals x over 25. Because by putting that over 1, we're not really changing anything. Now we need to cross multiply this. So I get 1 times x equals 25 times the sine of 64, which means x equals 25 times the sine of 64. And this is where you just pull out your calculator. We need to make sure it is in degree mode. So if you have your calculator with you, this shows you how to put in degree mode. And so you click that mode button right next to second, I think. And you have to go down 3 that says radian and degree. Move it over so it's on degree. Okay? And you put that in your calculator and you should get 22.469. It asks us to round to the nearest tenth, so that's 22.5. Okay? Let's look at example C. So again, I'm going to start by labeling. So 34 is my hypotenuse. If I draw an angle or a line, I hit the opposite side, which means x must be the adjacent side. So I need to look and see which one uses adjacent and hypotenuse. This one is cosine, because C equals A over H, cosine equals A over H. And I'm just going to write this out. So cosine of the angle, so cosine of 18 equals x, the adjacent side, over the hypotenuse. Create them both into fractions, cross multiply, and I get x equals 34 cosine of 18. Again, just put that into your calculator, and you should get 32.3359, which is 32.3. Okay? Let's do this one last example. So again, let's start by labeling our sides. The longest side is my hypotenuse. I'm going to draw a line from my angle, and I hit the opposite side. And then whatever one I don't touch is the adjacent side. So I have to see which one uses opposite and adjacent. This is tangent. So I have the tangent of my angle, so tangent of 35 equals 9 over x. Put them both over 1, cross multiply. So I get 1 times 9 equals x times the tangent of 35. Well, 1 times 9 is just 9. Now I have 9 equals x times tangent of 35. I need to get that x by itself, so it's being multiplied by tangent of 35. Opposite of multiplication is division, so I'm going to divide by the tangent of 35. Tangent of 35 divided by tangent of 35 is gone, so I'm left with x equals 9 divided by the tangent of 35. When you put this into your calculator, I want you to make sure you put the bottom in parentheses. So it would be 9 and then the 9, then division side, then parentheses, tangent, parentheses 35, close parentheses, close it one more time. Just to make sure we're getting the right answers, okay? And you should get 12.85, which is 12.9. Okay, we're going to save the applications for class because this video is too long as it is. I will see you guys tomorrow. Make sure you take the quiz.